Hello, everybody. We are just about to get started here. So as people sign in, if you can just wait for a few minutes and then we'll get started. Okay, I think now is a good time to get started. Looks like quite a few of you have signed in. So welcome everybody, Moldflow users, enthusiasts, geeks, or anyone else just curious about Moldflow. Whether you're a seasoned Moldflow veteran or you're just interested to see what Moldflow is all about, we're going to be here to talk about the much anticipated release of Moldflow 2021. So thank you for registering. We received all of your questions. If any questions come up during the presentation, feel free to use the questions section on your webinar control panel, and our intrepid question taker, Kate Shappett, will help sort all that out, and we'll have a Q&A section at the end, along with the questions that you guys submitted prior to the webinar. So I'm Tim Lankish, Director of Engineering at CAE Services, and we're hosting this along with Hanno van Raalte of Autodesk. And just a little bit about ourselves. So Hanno is a legendary Autodesk Moldflow team member. He's a Moldflow product manager. He's not just legendary for everything about Moldflow. I've also witnessed Hanno's dance skills on the dance floor at the old Autodesk University. So he's not just legendary for Moldflow. He's got some wicked dance skills too. Hanno started a while ago with the old C-Mold product in 1997 back in the Netherlands. He moved over to Ithaca with the Moldflow development team in 2001 and became the Moldflow product manager in 2007 and has been in that position ever since. So Hanno's done a really good job with directing the Moldflow product over all these years. As for me, I'm a legend in my own mind, but I've been around for 27 years here at CAE Services. I'm expert certified. I've trained 15 plus expert certified engineers, Trade Magazine contributor, Moldflow Summit presenter. And by the way, the Advanced Design and Manufacturing Summit that was held back in August, I believe all of those presentations are available online somewhere, and maybe Hanno and Kate can point us to that at the end of the webinar here. There's my email if you have any questions after the fact today. A little bit about CAE Services. We were established back in 1988. We have the most expert certified Moldflow engineers in the world. More recently, we've become an Autodesk partner, tasked with consulting, software, and training. And in the consulting world, we've completed some 24,000 plus projects over the years. So we've got a wealth of knowledge and experience in the Moldflow world. And there's our website if you want more information about us. Autodesk more recently, and when they acquired Moldflow back in the day, you know, over the years they have done a really good job of really becoming a company that embraces everything, the whole gamut of products that get you from design to through simulation and on to manufacturing. So these are all the different products that are involved in that process. And most of you probably know, but many of you may not know that you also have a product called Fusion 360. With every license of Moldflow that you own, you have access to Fusion 360 to be kind of that central hub for CAD for all these different products, where it seamlessly integrates your CAD product back and forth among all these different software products. So that's where Autodesk is heading. It's their "Make Anything" slogan that really drives home this point. So our agenda for today, we're going to talk about Moldflow 2021, obviously, security hardening, the simulation compute manager. This is one of the biggest requests and areas that Autodesk put a lot of focus on for this release, and Hanno will talk more about that. We'll talk about solver updates and new capabilities and some other changes as well. So with that, I'll hand it over to Hanno, and he can talk about the new release.
Cool. Thank you very much for the introduction, Tim. That was pretty legendary, I want to say. To start off with your presentation, you mentioned like we had the Advanced Manufacturing Summit in a couple months ago, and now actually in hopefully a week or so we will be able to host all those presentations we've done there on the Autodesk.com, as well as we're posting these on YouTube. So just get it out of the way before we forget about this question. It's pretty important, I think. So to start a presentation, like, so my first component, actually, well, I want to actually take a step back and think about like where we have been so far. So if you think about Synergy, it's almost 20 years old now, and so our user interface. And when we think back 20 years, which is almost impossible. So for some people on this call, I'm sure, but a computer was a very different machine than it is nowadays. Like, so, I mean, when I think about 20 years ago, a good state-of-the-art machine that was going to give you the fastest performance had 2 CPUs on board on a motherboard, and then there was still a single core and very limited RAM and disk space. When we think about it as a also a somehow we think about like what is a phone is a very different thing nowadays than what we like think of a phone nowadays. So it's the world has changed significantly. Also, like when we work 20 years ago, a lot of people worked in projects very sequentially. So analysis would be done by a person, throw it over the wall, and somebody else would pick it up and do the next thing. Much more very waterfall, if you will, like very much like step by step by step. And it was pretty. It's still done with a lot of customers, but you see a big shift in the way people work nowadays as well. And also, like nowadays, what we think about as our office is very different as well. Like, and even until last year, for most of it, the office was the office, and now a lot of us are working from home. When we think about like compute platforms, like this is now for many customers or our users, what a computer looks like, what we work with nowadays. It's a lot more, even though it's a lot smaller, it is much more powerful than it was before. Where data is actually not only, like in many cases, not only on your local machine, but in very many cases is also like on a different place in the universe, like for instance a cloud. Also, when you think about like computing, it's not just a computer anymore, but also like looking at tablets and even like our phones, and because our phones have transformed from typical phone that you make a call with to a data consumption device. So, and all those things starting to become part of what we as software vendors and software suppliers have to consider what people are going to be doing, right? So not only creating data with, let's say, a laptop, but making it available to somebody on the other side of the world that's making the data accessible or accessing the data maybe with an iPad. So those things are going to be big changes that we're going to expect over the next couple of years that are going to be much more commonplace than they were before. Also, the way we work is very different nowadays. Like it's much more teamwork or like distributed places, particularly right now with a lot of us working from home and in virtual teams. Like we now see where, let's say, cloud and accessibility becomes a big component of how we expect to operate in the not only in the near term but also longer term, because these things are going to have longer term effects. The infrastructure being put in place now to be much more working remotely, and when that infrastructure is there, we expect people to continue to use that at some point. But so if I think about like where we expect things to go in the next couple of years, like there's a couple of big pillars that I want to circulate around a little bit and think about, give you a bit of a view of where we are expecting to land in the next, let's say, 3 to 5 years. I mentioned like data does not only reside in your hard disk anymore, it resides in many cases in the cloud, and it could be, let's say, a cloud application like our own Autodesk Teams, but it could also be, think about how many companies are not using Microsoft Teams or using SharePoint to collaborate with the internal team or external team members. So data sharing and data collaboration is going to be a key component of what people expect from how things work in the foreseeable future. And also, like, I think what we consider to be data it's going to change. So it's not only going to be, let's say, a design or a simulation data. It's going to be possibly involve data, how something is manufactured. Let's say shot-to-shots data created on your injection molding machine, or think about maybe customer input data, like usage data. So all those things become part of data sets, bigger data sets than we've ever had before. And all those big data sets and rich data sets are going to allow us as users and companies to start making better decisions for our products. It's going to lead us not only to streamline workflows through automation, for instance. Like, I mean, that's the bare bones of what we expect from the future there, but also like getting insights that are not trivial to get from massive amount of data. Think about how many shots a injection molding machine or like a factory would produce, and can we derive insights on like how, when we expect let's say, next round of maintenance to occur in a specific mold, because we now get insight, we have data we can actually do something with. So those are the things I think are going to help us like go to the next level, and we have to prepare for that. We're not going to be there overnight. These are very big projects, but those are things that we expect become more and more important for the future as well. And also, like what compute power means is going to change. Like it's not only going to be more power available from anywhere on demand, but also going to be like, hey, the hardware is going to be different. For instance, my daughter is now going to school, and she's running going to school, virtual school, homeschool with a Chromebook, and that's a low-end $100 machine. And we still expect that thing to be able to do everything a normal Windows machine does, right? So the expectations that lower-end hardware are going to provide the same type of quality services as what we expect from high-end machines is going to come with it. And then those things are like going to require us to move what compute power, how to access compute power. So like your local machine doesn't actually have the compute power to do things that are difficult, but you have a lot of compute power available on demand in the cloud. So you can actually move a lot of that data heavy and compute heavy work to a cloud, for instance. So keep that in mind with where we want to go, and so we putting the pieces together for this right now, and we expect those things, these big drivers, to influence our directions very extensively. So next slide. So first piece that I want to talk about is related to like the fact that we are expecting data in the cloud to become more and more important, right? So, and we've had, when we first started talking about cloud computing back in the days, like 10 years ago in Moldflow or in Autodesk with Moldflow, I mean, many customers were saying like, never, we cannot put our data in cloud, and that will never happen with us. And now the situation is quite different, because like people actually have much more sophisticated answers to those questions, and that's a really good thing. And we're getting now actually much more sophisticated questions about like, hey, so when we talk about you as Autodesk talk about cloud computing and data in the cloud, how do you secure your data? And that's a very important question. And we have put together as a company a specialist set of people that are, I mean, they're security experts. They know how to develop code securely, and they basically help us across the product portfolio with defining how we should develop software, what we have to do to make sure our code is secure, put protocols in place to, let's say, scan our source code for potentially vulnerabilities and alert us to it, do those things, and then we can fix those. And all those things actually are pretty, they help us actually becoming taking more ownership over this problem, right? So at the end of the day, we want to get to a situation where you as a company trust your data behind your firewall, and you want to trust us as well with your data as well as it is trusted behind your firewall. So we want to make sure that data that you give us to own at some point is going to be as reliable or than as it was in your firewall. So, and we're going to continue to invest in this area. This is not going to be a one and done. This is actually a very, very big piece of what we did in the last years. I mean, this was literally 9 to 12 months out of our entire development team, actually bringing it up to par, because we have so much legacy code in Moldflow that needed to be brought up to meet the requirements that others were setting for us. Next slide. So the next piece is, this is related to the previous slide, is like we actually have a new simulation compute manager, is SCM we call it now, and that's the replacement for the old SJM. the old job manager, and now actually it's built from the ground up with security built into the system. So it's state of the art. It has all the certifications that we have in Autodesk. At Cloud Backend is all that state of the art cloud, meeting all those and more requirements that were set for us in terms of cloud security. And it is going to be a very fundamental piece to us moving forward. So beyond that, it is one of the other reasons why we actually developed this was we wanted to make sure that the job manager that has plagued us for like a couple of years was replaced with a much more reliable job manager. So like, it's a pretty fundamental piece. When you submit a job, it has the results have to come back, right? So we had experienced problems with this with the last job manager, where like it was working most of the time, but in some certain circumstances, the results were not coming back reliably. So we have now had this new SCM tested in the last beta. We've been running a beta for over a couple of months, and we had actually a lot of good feedback from that. So we have a high degree of confidence that once you submit a job, the results are coming back. It has also a new batch queue-driven workflow, so you can, as let's say a company, let's say 5 of your Moldflow using colleagues can all submit your jobs to this one particular queue, and let's say other workers were in a cluster or whatever you have can pick up jobs from that job queue. I'll show a bit more about this later in the presentation. So basic workflow for the new job manager is, so this is 2021. I'm signed in over here into the cloud. That is an option that you don't have to be signed in. And when you hit the analyze button, it will pop up a new launch window. That launch window will allow you to submit in the cloud to your local machine, or I can add another machine to this. And this is my machine that's sitting next to me. So I'm going to add this machine to it right now. My little machine, computer. And I add that right now, and it makes a connection now with my other machine that's also available on the network. So important is that my machine and my little computer have to be able to see each other over the network. So either through VPN or directly in the on your company network. So I can launch a job from here, and that's basically the basic workflow on how to submit a job. So the next video is going to be how to like use the SCM, the new job viewer. So starting again with an analysis that actually is running. Sign in, and I have something that have some intermediate results there. I have a screen outputs that I'm getting, and now I can view either on my local my machine or my little machine that I added. I can view the analysis queue on those machines. So in this particular case, I'm looking at my local machine, and I can see my analysis is running there. So I have a couple of options here. I can see the sequence here. I can view the log. So I can actually view the log, Moldflow log, without actually having to have Moldflow installed on the machine. I can actually use it, access this viewer from any machine on the network, or even let's say my iPad. As long as the connecting machine can actually view this machine, see this machine, I can pop up a browser and actually point look at what's happening on that local machine. So this basically is a browser-based viewer. It doesn't actually connect to the internet per se. It's really just hosting a local web service that you can view with browsers like Edge or Chrome. So there's a couple of options you have. You can actually, let's say, filter by different statuses. I can look at what's running, what jobs completed. I can order things in any way I want to. And I can also like look at my other machine. So from my local machine, I can look at a distribution queue from another machine. This is the other computer I was added earlier. So I can have in one browser my local queue as well as view my remote queue. So again, you have the same options. I can filter and whatever you have there. Good. So next slide. Okay, so I can also add my machine to another machine's distribution queue. So when I go back to the job viewer, I can either do it in viewer mode or I can configuration mode. In the configuration mode, I can add my machine, my local machine, to another computer's distribution queue. And at that point, I can basically, if the other remote machine has jobs waiting to be solved, my machine can look at that queue and say, hey, can I pick up a job there? So add my machine now to another queue, and it will pull, if there is anything to be solved, my local machine will pull something from the third server. So it will pull it. So in the old job manager, you would push a job from one machine to another. In this particular case, I can add my machine to another queue for it to pull jobs from. So there's a pretty fundamental change in the way you think about it. But particularly for larger companies with, let's say, multiple users, and this might actually be a really interesting way to get through a lot of work very quickly. So you can also add your machine to multiple queues. So I can have, let's say, 3 machines with different queues set up, and I can put my machine to every one of those 3 queues, and you have a lot of freedom to customize things by the way you want to. For instance, you can set up a queue for small jobs and just have that serviced by smaller machines, and let's say a queue for priority jobs and have that be serviced by like bigger machines. There's a lot of things you can do with this. Yeah, that's I think enough about this particular thing. Another thing I wanted to spend a bit of time on is to set up concurrent job limits. So if I actually want to submit, let's say, a couple of machines, a couple of jobs to my machine, but I want to make sure that my machine doesn't get overloaded. So I can, instead of the default number of jobs that I'm submitting, I can set it, let's say, from 3 to 2. And at that point, I can, when I submit, let's say, 4 jobs, which I'm going to do next, I'm going to submit 4 jobs at the same time. Only 2 of them will be running at the same time by my machine. So I'm going to submit it to my local machine, and I'll only grant the right of 2 jobs to be run at the same time. Everything else is going to be end up in a scheduled state. So when this is done, I can now go to the job viewer. And if I move the jobs that were completed or ended, I can see that I have 2 jobs that are running and the other 2 are in pending state. So as soon as one of the jobs completes, the other job, another job will start launching when it's possible. So I think that's enough about a job manager. So I'm handing it back to Tim for the rest of the presentation, and we'll helping with answering questions later.
Okay, thank you, Hanno. So the next portion of this webinar is going to be all about solver updates and new capabilities. As you can see, a big part of what Autodesk has done with Moldflow is focused on the simulation compute manager, but of course there are new updates and capabilities as well, so I'll go through those. One of the big ones is improved sync marks. You know, over the years, one of the biggest things that has been requested of Autodesk with regards to Moldflow has been the ability to do a better job of picking up aesthetic appearance issues in general, but sync marks in particular. So the you know, and with the different types of meshes, midplane, dual domain, 3D, the 3D has always had kind of its own algorithm for predicting sync marks. Well, they've now got it to the point where things are predicting sync marks in 3D much closer to what midplane and dual domain are doing. So it's a better prediction. It's able to capture sync marks on wide and shallow structures. So you can see with these wider ribs, we'll call them, it's still able to pick up those sync marks, whereas in the previous versions, we didn't see those being picked up. Here's just some validation work that has been done. So this is 1, 2, and 3 millimeter thick ribs on the back side of this plaque mold ASA material. It did some laser scanning on the sync mark depth, and you can see here on the graph that they imposed different levels of pack pressure on the molding as well. So you can see the correlation there and the influence of the pack pressure. So obviously, as the pack pressure increases, you should see a decrease in the sync mark depth, and that's what you see here in the graph. Here's a little closer look at experimental results versus simulated results, and you can see how much closer in gray there it came to the experiment in blue compared to 2019 in orange here. So that's for both the 1 millimeter rib and for the 3 millimeter rib. So the sync mark predictions are getting better in 3D. We also have some new visualization options. So there's new legend options to help people with color blindness, for example, or to allow visualization of results closer to experimental data. So, you know, like black body or cool to warm or anything that, you know, might show up like on an infrared scan of a tool, for example, or grayscale over here. We'll pull this next slide up here for the ability to show visible flow marks on polymers with metal flakes, for example. So you can use this grayscale for that option as well. Birefringence on grayscale has a new visualization option to better view the birefringence patterns, for example, in these glasses. Another nice feature that's been added is automatic packing profile. A little bit of a misnomer. It's not necessarily a full-blown profile. It is available in Insight and in Adviser. And it's not the default option at this point. You hit a drop-down box and you can bring it up, but it's available for midplane, dual domain, and 3D, and it's aimed at minimizing shrinkage within the constraints of the molding machine that you are intending to run this in. So at the VP switchover, it's going to choose a packing pressure and a packing time based on 80% of or the lowest of 80% of maximum injection pressure or 80% of max clamp force based on the projected area. So be a little bit careful with this because you may get some shrinkages that are a little bit on the low side for a given material, but it's a good starting point for you to help, number one, figure out the packing time, but also to set your packing pressure level so that it does fit in the machine that you're going to run it in. Oops. So it's going to base the packing duration. It says here it's usually an overestimate, which is fine because once the gate's frozen, then you can't really pack it out anymore anyway. But it's going to base that on the rate of mass change, and this is how you would run, for example, gate freeze study at the press. You would gradually increase the time that you're going to pack until the you don't see a discernible change in the mass of the part. We also have improvements for semi-crystalline materials. So, and this is for 3D. It's always, in the current version of Moldflow, it's very successful for the midplane and dual domain versions of mesh. But in 2021, we have a more accurate shrinkage and warpage prediction from 3D. It's more consistent volumetric shrinkage results between midplane, dual domain, and 3D, and generally results in slightly higher volumetric shrinkage compared to prior releases. So here on the left, we see the 3D average volumetric shrinkage in 2019. And when we jump to 2021 here, you see the increase in the shrinkage values. But also you see that it compares very nicely to the dual domain results, for example. And we would expect the same thing from midplane. So the idea here is that the 3D product is getting closer and closer to what the traditional midplane and dual domain results have been over the years. And in this case, it's for the semi-crystalline materials. This does not require new material data, so yay, right? Don't have to get any additional material testing for that. Here's a look at some of the deflection results that we see, comparing them to 2019 on the left in 3D. Here's the dual domain result and then the new 3D result. So you can see the 3D result, again, as a function of the improvements in the shrinkage calculations, translate over to more consistent deflection results compared to dual domain and midplane. Another thing that's been introduced here is insert to insert contact in 3D warp. Used to be that, as you see on the left here, we have a mesh with overmold, that's the plastic. We have insert number 1 and insert number 2, and if you had that situation, Moldflow wouldn't understand that the two inserts are somehow connected, and so you would get things like the plastic material passing through insert number 2, for example. So that's been corrected, and that shows up now properly in 2021, where everything moves as one unit in the deflection results. Essentially, these inserts are glued together. Other solver improvements. So improvements to the mechanical property calculation. There's a minor change in the midplane and dual domain for some materials that's now consistent with 3D. Small improved mechanical properties for fiber-filled or disc-filled polymers. 3D flow improvements. We have improved 3D weld surface prediction, and I'll show you some pictures of that in a minute. We have improved 3D flow, valve gate stability and control. There's an accuracy improvement in the 3D core shift calculations. We have improved 3D microcellular or mucell foaming prediction, better structure, mechanical properties, and warpage for that. For midplane and dual domain flow, we have improved barrel compressibility, which will show up in pressure and thermal calculations. And then now it also writes profiled results by default. So for example, if you're doing a profile across the thickness of temperature or any of the things that you might do across the thickness, those results will be written by default. And then there's also, for those of you who use the boundary element solver for cooling, which is the traditional cooling analysis, the numerical precision has been improved on that as well. Here's a look at some of the weld surface prediction improvements. So on the left here, we have the initial weld surface position shown there, and then we have the weld position after packing flow on the left. On the right, we see weld surfaces. For example, in 2019, there were broken weld surfaces. And if you do any work with like structural analysis, passing weld line predictions on to do weld line strength calculations, this is a problem, broken weld surfaces. So now that's been corrected in 2021. We have continuous weld surface prediction there. We have solver API changes for those of you who like to geek out and get into the deep into the solver API. It's now available in Insight Standard, Premium, and Ultimate subscription licenses. It has a new solver API option for user node fields, for fiber orientation, and for injection and time step control. This one I love, 3D buckling analysis can utilize mesh aggregation. So for any of you who has ever attempted a 3D buckling analysis, you know how long that can take to run. So this is now 10 times faster and requires 75% less memory. So that's a great addition, in my opinion. They've improved cases of bad surface mesh aspect ratio, so improvement to the mesher there. In those cases where you're creating a surface mesh and the aspect ratios don't work out. So just some further improvements to the mesher there. They've added RAM position to screen output. So this is great for if you know the screw and barrel diameter ahead of time of the machine you're going to run it in. Let's say, for example, you've got valve gates and you're going to time your valve gate sequence. It's good to be able to output those RAM positions so you don't have to calculate them, kind of back calculate them and see where everything is opening. So that's nice to have on the screen output in the XY plots. Also introduced this new foaming option. Mentioned a little bit about MuCell earlier. There's now reactive MuCell injection molding. So that's essentially thermosets. The chemical foam molding injection methods. We have two different ways to do it. You can have the material injected just like you would in a standard analysis without foaming. You essentially control the filling and then you decide when to switch over, and it would be a very early switch over, of course, and let the foaming take over from there. Or you can specify an initial charge where you specify the 3D elements that are going to be filled initially and go from there. Here's just a quick experiment versus simulation on that. So you can see good agreement between the simulation and the experiment. Other changes, here the CAD file formats. Of course, Autodesk Moldflow wants to be very open to all the different CAD packages out there. It used to be back in the day that we had to buy a separate translator package and all that. But that hasn't been the case for a while. But continuously upgrading and updating, keeping up to date with the different versions of all the different CAD packages out there is important. So these are the updates to that. And then, of course, the material database. This is kind of the crown jewel of Moldflow. 11,000, almost 11,500 materials, and constantly updating. Adding, subtracting, making sure the database is as clean as it possibly can be. So we're up to 11,500. Total number of suppliers is 569, so that's quite impressive. So here's some advice as you're going through this process. Oftentimes people want to kind of wait until they install 2021. Autodesk really has done a good job of getting this 2021 product on board with beta testing. So, but when you decide to make that leap and load 2021 up, rely on the experts. Rely on us, rely on Autodesk, whoever you can get your hands on. We're here to help you make that transition. We're an Autodesk partner, as I mentioned before, so we're tasked with those software sales, the training, and probably most importantly, the mentoring side of things. So for the software, if you're on and you never had Moldflow before, you're just kind of checking things out, we do have demo days that we hold. So just give us a call, and we'd be happy to show you more in depth what Moldflow is all about, whether it's Advisor or Insight. Learning, our motto is building expert analysts. So we do training, classroom and online. Classroom is a bit on hold these days because of the COVID situation, but we are doing online training. So just visit our website and look in the learning section, and you'll see a calendar of upcoming classes. This is the Ask the Moldflow Experts. We do monthly topics, so keep your eyes peeled for newsletters, and of course you can always jump on our website to check out what's coming up. And then we also do a thing called Moldflow Office Hours, which is kind of nice. So if you just have any old topic about Moldflow that you want to discuss in depth, you can spend an hour with us at a time and just shoot the breeze on Moldflow. You can have anything from very broad set of questions to something very in depth that you've been wanting to learn and just haven't taken the time to. You can use the office hours to help you get there. So that's pretty much it in a nutshell. Again, we're excited about the release. It's been a while in coming, but you know, again, Autodesk and the Moldflow team have done a very thorough job of combing through the code, making sure it's you know, got more modern security in it, and just a better, cleaner product overall. So. And of course, they've included quite a few upgrades as well. So we're excited to have the new product out, and we're excited for all of you to be able to jump on board and give it a go. So as I mentioned, feel free to call me, email me, check our website out at any time, and ask any questions you want. So with that, we will turn it over to the question and answer session. So Kate, what do you got for us out there?
Yep, thank you, and good job to the legends today. Definitely some questions coming in. Everybody, as you know, when you signed up, you were also asked to submit some questions, so we can answer some of those as well. There were several themes. So we'll just start with the Q&A questions from GoTo first, and then we can pop over to some of the other ones if need be. So the first question is the job view in the SCM going to require admin rights to view, and what is in queue by multiple users?
So I can answer that. So the job viewer is just a browser viewer, and as long as your machine that you are trying to access this from can see the machine that has the queue, you can view it. So there's not particular admin rights that are going to be required to view the queue.
And then along those lines, is this the same for Advisor?
Yeah, it's using the same job manager in the back. Yeah, it's the same component being used.
Okay, what if you want to run jobs with an older version?
So the older versions still require to have the other product installed. So the 2021 job manager, it makes a clear cut from this release and prior releases. So you cannot submit a job from, let's say, Synergy 2021 to a solver, let's say 2018. That doesn't work that way. We had to basically do a lot of rejigging of how the solvers communicate with the job manager, as well as how the job manager communicates with Synergy. It's been completely rewritten, so there's no way to make that work with prior versions. Going forward, however, let's say 2022, we expect to use the same shared job manager with the current job manager. So going forward, we'll be using a shared component there. So it will still be, let's say 2020, Moldflow 2022 Synergy will submit to a 2022 Insight solver, because the input file, the study file, is really version specific. So you cannot, for instance, if we were to say have in 2021 release now, I'm setting up a foaming analysis, a foam molding analysis, and I want to submit it to a 2018 solver, which doesn't know about foaming there, that would be a big problem, right? So we have to always make sure that the study file, creating the user interface, and the solvers are the same, so they understand each other.
Makes sense. Does the new job manager allow for you, the user, to get estimated times back for the results?
Not at the moment. That actually is a pretty significant task to predict how long this thing going to take. You never know if you're going to run into, let's say, hardware issues or like running out of memory, and all of a sudden, like the speed will go down significantly. So it's hard to predict that for us ahead of time. But I think in the next foreseeable future, I suspect we're going to spend some time on at least ballparking if a job is going to be a small job or a medium job or a large job. I would not be surprised that actually we're going to at some point spend some time on that to help us sort of predicting it a little bit more. But that's as good of an answer I can give you right now.
Makes sense. Will the job manager allow for jobs to be submitted from a PC to a Linux cluster?
Yeah, that actually has been available for a while. Even the old job manager has that in a roundabout way. The new job manager will also allow you to submit to a cluster, and there are ways to maybe even tap into the cluster management systems a bit more than we had before. So yeah.
Alrighty, switching gears from the SCM to syncmark results, does the material characteristic quality affect the syncmark result?
You want to take that, Tim, or?
Not sure what they mean by material characteristic quality. So basically, sync marks are the calculation for sync mark is essentially based on three things. It's the thickness of the part in the area in question, the distance from the gate, so the pressure that's available to it, and the temperature of the material in that area. So to the extent that you have a well characterized material, the sync mark prediction depends on that material data. So a lot of it just boils down to good material data. And of course, with good pressure predictions, things like juncture loss become important. All of those things that go into pressure calculation. So not sure if that answers the question properly, but the code is certainly improved, the calculation is improved, and of course the calculation depends on all those things I just mentioned.
If that doesn't answer that question, the asker can, restate, and I can clarify later or after the webinar. The next question, so this customer, their parts are quite decorative. They are asking, how can we tell our customers that the sync marks are cosmetically visible?
Yeah, I'll take that one again. So Moldflow doesn't have a yes or no answer to that question. A lot of it depends on obviously the type of material that you are molding. Also depends on the level of gloss that is being applied to that mold surface. So a lot of what I've seen out there is customers really just kind of doing their own type of testing. So they take Moldflow results, for example, and say, okay, when I hit this level of sync mark, I see a visible, it becomes visible. Okay, so it's basically mapping real world results. If you've got a scanner, great, do it that way. Or if you just do it visually, you can do it that way as well. But it's basically just mapping things back to real world molded samples and noting the point at which you see a visible sync mark in Moldflow. So it may be 0.1 millimeters, it may be 0.2 millimeters, maybe 0.05 millimeters. But that's generally the way we've seen it done, and that's the way we've used it. So it's a material by material situation, case by case situation, and it's not the case that Moldflow can actually give you a yes or no answer on that.
What I would actually say is like, if you have, let's say, and it's also a bit dependent on what your tolerances are, right? So I think if you have something with a sync mark on the back of hardly visible area, your tolerance for a sync mark is going to be much higher than if you have a bumper fascia, for instance. I mean, that becomes a much more critical area, right? So it's hard for us to put a hard number on this is visible, not visible. That said, I would start, if I were you, I would start with like, do we have any rules established internally for how deep a sync mark can be? And then set a threshold for that. So we actually are working on this area. See what we can do there. We have clearly some visualization capabilities in Autodesk that we might be able to tap into. But yeah, it's not a black or white thing. Like I said, you have no way to accommodate what you decide to be tolerable, if you will. So.
Along the lines of cosmetics, there's a question here asking if there are any improvements in estimating the flow lines and blush defects on a part.
Not explicitly, and I think so. One thing that I think I want to see if I can expose a bit more, or at least think about a bit more, is can we use sort of new visualization tools to, let's say the new, for instance, grayscale, or to highlight areas that are maybe exceeding certain thresholds for, I mean, shear, or that we can start detecting these things a bit more easily. Like I said, it's a new area for the new legends bar options are fairly new for us, so it's still something we see what we can do with it. I suspect there may be a few things that we can do there to give some better answers. It's hard to at the moment to say. I do not have an explicit algorithm for blush effects, for instance, but if we can actually say like, this area is exceeding the blush tolerance, or like some shear shear tolerance maybe in the model, maybe we can actually highlight areas that are exceeding are violating the rules.
Any more questions, Kate?
There is one in here with respect to material characterization quality, and how we well, has the benchmark for material characteristic quality been changed? For example, getting gold requires the pressure dependent viscosity. We can take that offline too.
Yeah, that's a little more in depth, but I mean, essentially, nothing's changed with the upgrade to the next level of software. Good characterization is good characterization. You know, the more that's included in the material characterization, of course, is going to go a long way towards getting better pressure predictions and so forth. So to the extent that you characterize it well, you can expect better results. That'll never change with Moldflow.
So the last question I think we'll get to today, because I realize there's about 2 or 3 minutes, is around crims for 3D. I know that we aren't calling this crims for 3D, and Tim, you spoke to this a little bit. Do we want to address that a little bit more with the audience here? What are we officially calling this?
Officially? I don't think it has an official name.
Officially.
So we actually do not have a proper name for it yet. It is, we are looking to allowing the 3D warp solver to take advantage of measured data along similar lines to what we do with crims correcting shrinkage for plane dual domain. We had something in the technology preview, Scandium, that was basically for, I believe, unfilled semi-crystalline materials. We're now actually adding filled materials to it and other material types. So it is an area that we're actively working on. It's showing some really good potential. It's not done yet. So we're, like I said, that's working on. This is going to be for a future release, but it is definitely an area that we are pretty bullish on, that we can get out in the foreseeable future.
Cool. And then last but not least, Tim, where will this be hosted for consumption afterwards?
Yeah, we'll put the PowerPoint on our website, or actually a recording of not the PowerPoint, but the recording of the presentation on our website. And so look for it there, www.caeservices.com. Okay, well, I think that about covers it. Our hour is up. I wanted to say thank you to everybody that has attended and submitted questions. We hope it was informative. Again, we're excited about this release, so feel free to contact me or anyone in the Autodesk team at any time for any help with that. I want to say thank you to Hanno for putting a good portion of this presentation together, if not most of it. Thanks to Kate for monitoring the questions, and again, thanks to everybody out there. So look for the recording on the website, and look for us next month for the next Ask the Moldflow Experts webinar. Thanks, everybody. Have a good day.